Hello, this is Katie, and we are going to work on the Chapter 4 homework assignment. First of all, in the Chapter 4 Learning Module 4, there's a quick cheat sheet, sorta, on your IP address classes. Class A, B, C, D, and E. A, B, and C are used for networking. The first octet can tell you what class of IPs you are in, and then the default subnet mask is down here. From this, we can also tell, unless subnetting is going on, we can tell which is the network part and which is the host part. So these are very important concepts explained in this chapter, and I've given you the entire subnetting workbook. This is from Cisco's CCNA training and CCENT training. This is a good reference. You might want to download it and just store it away for when you get really bored and you want to practice some subnetting. We're not doing the entire workbook because it is 100 or so pages, but we are going to do select things out of this workbook that I've included in the homework assignment. With this workbook, I also provided a long video. You don't really have to watch this unless you go beyond the scope of homework 4. And then some additional videos, quizzes, and such with this learning module. So let's go over to the homework assignment. The first to begin with, we have our basic definitions. These are all very important concepts from Chapter 4. And I know definitions are kind of boring, but there aren't a lot of questions in this textbook and with these materials. But if you're preparing for the CCENT, it's important to know these basic terminology. So especially the routing, we don't cover so much with the homework, so make sure you read on IP routing. And in the future, we're going to use a tool that will called Packet Tracer that will allow us to set up these type of routing scenarios. So make sure you read the chapter closely. Now, beginning with question 2, we have 6 tables that you're going to do to work on binary conversion. Now, when you're given any set of IP, I have a scratch pad up here I'm going to pull up, but when you have any IP address like 143.89.57.145, when you have any IP address, this is called dotted decimal notation, and then you can convert it into the binary notation, and that's a series of 32 ones and zeros, so 32 binary numbers, and each set of 8 is called an octet. So that again is explained in the chapter, and what we're doing with the assignment, oh, for Pete's sake, what we're doing with the assignment is we are going to learn the conversion from binary to decimal, decimal to conversion, subnet mask, and class identification. Now, it's a little repetitive if you've done this before, and it's a little repetitive when you get about to question 6 in each of these tables, because once you figure it out, it should be a piece of cake. Excuse me. Okay. Table 1, binary to decimal conversion. You're given an 8-bit stream right here, and you need to tell me what the answer is in dotted decimal notation or decimal conversion. So you can use your handy calculator, and in the programmer part of this calculator on Windows, some systems are just the scientific, but you can use the binary calculator as well. I don't like to teach you that because when you do a binary conversion, it doesn't give you the trailing zeros, and if you don't understand the concepts, you're going to look like a fool and give wrong numbers. But when you take any number such as 119 or 146 or whatever, or 255, there is a series of 8 ones and zeros that represent the decimal or the binary format of this decimal number. So let's look at question 1. The answer is 146. And how we got to that is anywhere that there's a 1, we added it up. So 128 plus 16 plus 2 equals 146, and that's there. Now we did the same with question 2. Anywhere that there's a 1, we added it up. 64, 32, plus 16, plus 8, plus 4, plus 2. Nope, did I miss one? Not 8. 64 plus 32 plus 16 plus 4 plus 2 plus 1 is 119, and that's the decimal conversion. Anywhere there's a series of all ones, that's 255. So when you go on to question 4, not that screen, when we go on to question 4, you just go ahead and add up anywhere that there's a 1. So 128 plus 64 plus 8, so 128, 64, 8, and 1. 128, I'm checking because these numbers are all looking the same. 128, 64, 8, 1, 201. There we go. So you want to finish out that table. Now the next table has you doing the opposite. So you are given a binary, you are giving a decimal number and you're going to convert it to binary. So what you want to do is, I have a little cheat sheet or a little scratch pad so I can so it'll help me with the math. But all, again, you need to remember is this table: 128, 64, 32, 16, 8, 4, 2, and 1. And when you start with your number, so I'm going to start with question 1, anywhere there's a series of 1 is 255. Let's look at how they got to 231 with question 2. So let me move this down a little bit. I don't want to do that. Okay. Anywhere that there's a 1, you would add up the number. So what we're doing is we're saying, can we subtract, I like to use Excel because they have more room, but here's my 8 bit binary stream. And I'm going to have 1 or 0 or 1 or 1 or 0 or 1 or 0 or 1 in each one of these places. But what I'm going to start with is 231, and I'll ask my question, can I subtract 128 from 31 without going negative? And the answer is yes, so that becomes a 1. Now what I need to do is perform that calculation. 231 minus 128 equals 103. So now I say, can I take 103 minus 64 without going negative? Whoa, I was just going to pull over the calculation, but I'll do it the long way. 103 minus 64 without going negative, I can do that, so that becomes a 1. And then I have 39 left. Can I do 39 minus 32 without going negative? We can do that as well. So 39 minus 32 is 7. So we're not negative yet, so we can do a 1 there. And I have 7. 7 minus, 7 left. So let's just put 7 up here. And in this box, can we do equals this minus this without going negative? No, that's a negative, so that becomes 0. And then I still have 7 left, so 7 minus 8 without going negative. Let's do it the long way. We know that's also a no. No, we can't. So that becomes a 0. And I still have 7 left. Can I do 7 minus 4 without going negative? I can. It can be possible. 7 minus 4 is 3. So that becomes a 1. And I have 3 left. So 3 minus 2. So let's do that. Equals this box minus this box. And am I negative? No, so that becomes a 1. And then I have 1 left. 1, can I do 1 minus 1 without going negative? I can. It's 0, but 0 is not a negative number, so that becomes a 1 as well. And from 231, this becomes, or this is my binary conversion. So let's double check. 1, 1, 1, 0, 0, 1, 1, 1. We copy this chart and let's do the next one. And you can make this own chart up in Excel if you want. I am math, whoops. Sometimes I'm math impaired, especially at 12:30 in the morning, so I like Excel. Okay, our next number is 123. Well, first of all, let me clear these, clear contents. Hopefully my formulas still stick, but we'll see. Okay, so my next number is 123, and I am going to copy my formulas this time. Can I do this minus this without going negative? No, so that becomes a 0. Do you like my emphasis on no? I know. I wish I could. I would pull up the video right now too, but it's 12:30 at night, and I'm not going to pull up the video. Okay, so we have 123 we're still working with. Let me see if I can just zip this formula over. I've never taken an Excel class, and you guys probably have, but one time I interviewed at a place on Fuller. It was like a mental health hospital or some hospital there right by the jail, and it was for an Excel teacher. This was back in my 20s, and they had asked me a question about Excel, and I didn't know how to select multiple boxes that weren't together like this. I'm telling the story now. And because I didn't know how to do that, they did not hire me. And I was bummed out, but I think it was totally their loss because it was such a simple thing to figure out, but I didn't know it. I've never taken an Excel class. But anyway, what I just did was take my formula that I had here and I expanded it over, kind of copied it to each of my boxes. So there, you learned something in Excel. Okay, so here I have, ignore these numbers for now, but here I have 123. Can I subtract 64 from it without going negative? I can, so that becomes a 1. And then I have 59 left, so 59 minus 32 without going negative, I can do, so that becomes a 1. And then I have 27 left. Can I do that without going negative? I can, so that becomes a 1. And then I have 11. Can I do that? Yes. I have 3 left. Can I do that without going negative? No, so that becomes a 0. And then I have still 3 left. Could I do that without going negative? Yes, so that becomes a 1. And I have 1 left, so that becomes a 1 because it's not negative. So the binary equivalent of 123 is 0, 1, 1, 1, 1, 0, 1, 1. How can we check that? Well, remember, anywhere that there's a series of ones, we add it up. So let's add up 64 plus 32 plus 16 plus 8 plus 2 plus 1 is 123. Now this isn't that hard, it's just that you have to do subtraction. So if you've never done this before, it might benefit you to do one more, so I will do one more. If you want to pause the video and pick up after that and not do one more together, that's fine. But I think in my experience of teaching that it doesn't hurt to cover this a couple times. And I'm sure that guy who just dismissed me, he really did just dismiss me in my interview. He's probably been one of my students in the past, so ha for him. Still, I've never taken an Excel class, but I'm glad I'm not interviewing anymore. But good luck to you guys. You can do it, especially if you know all this smart stuff and you get certified. I'm going to set up, in Excel, I'm going to set up my formula first. It's going to be this box minus this box. And I'm going to spread just so you can see what I'm doing. And I'm going to take it and spread it all over there. We could even get super fancy and write an if statement. So if this is negative, make this a 0 if it's a positive. But I don't know that much in Excel, so we're not going to do that. If you've taken Excel, you can do it. Okay, our next number is 50. So we're going to say 50. Can we do that without going negative? No. So that's a 0. 50 without going negative? No. That's a 0. 50 without going negative, we can do, so that becomes a 1, and then we have 18 left. 18 minus 16 without going negative, yes, so that becomes a 1. We have 2 left. 2 minus 8, no. We still have 2 left. 2 minus 4, no. And we still have 2 left. 2 minus 2, yes, it's not negative, it's a 0. And then anything else, if we run out, becomes a 0. So the binary equivalent, the binary equivalent of 50 is 0, 0, 1, 1, 0, 0, 1, 1, 0. Again, all you have to remember, this table. Now this, well, I'm not going to save my homework because I want to erase those so you can do them through the video. But I like understanding IP. Once you understand IP and conversion, it'll make subnetting 100% easier. And bit borrowing, this is just your basic conversion. So once you get these tables, you'll get binary. You'll get subnetting. Now, the biggest problem that's introduced in this chapter 4 and with IP version 4 compared to IV version 6 is that with IP version 4 there's a limited number of IPs, so we have to expand it somehow, and what we do is we subnet until IP6s become everywhere on the internet, which it's been out for a long time. It's just not taking excuse me, it's not getting where it needs to be as fast as it needs to be. So we are still primarily using IP4. And it's important for you to know that, not only for testing, but also for your future employment. Let's look down at table 3 because we have 6 tables. These will go faster. Here's the class identification. Now, if you have to take a little sticky note and right in front of you, put 1 through 127 is Class A, 128 through 191 is Class B, and 192 to 223 is Class C. These are things you should know off the top of your head. If you're in help desk, if you're in network administration, engineering of course, but if you're graduating with a network administration degree, you need to know Class A, B, and C ranges off the top of your head. So how you determine this is from the first octet. Who cares about the rest of them? I've got a bunch of numbers in there, but it doesn't matter. 10 is a Class A. 150 is in a Class B range. 192 is in a Class C range. 148 is in a Class B range. All you have to know is the ranges, and that goes back to in the chapter and also in the notes here, the first octet. Excuse me. Remember 127 you're not going to see in the first octet typically. It's used for loopback testing unless you're doing loopback testing. So it'll be from 1 to 126. There's only 126 Class A's in the entire world. And then Class B's will range from 128 to 191. And then 192 to 223 for Class C. Now Class D and E are not used for networking. They're reserved for multicasting and experimental government secret use. I don't know what they'd use Class E's for. Table 4, this has to do with network identification. Now from a class, this is in the chapter, I'm not sure what page, but I'll explain it here. From a class, when you look at a class of IP, 177, we know that 177 is in a Class B. That means that the first two octets are the network address. So 119 is in a Class A, so the first octet is the network portion. The rest is the host portion. 209, so if we look at question 3, 209 is a Class C. So the network portion of this is 209.240, .80. I'm going to add that plus or that .0 on there because basically what that means is this would be the address of my router, and then all of my systems underneath it would fill out this box 1 through 255. 199, the next one, that's a Class C as well. So the first 3 octets would be the network portion. And it doesn't matter when you put this here if you do the .0.0.0. It might be easier for you to understand because then what you have here is a router. This would be the address of the router, and then you start to get into subnetting and all of the systems that are under there. Excuse me, I have a shaky voice for a minute. It's getting late. But I love subnetting. It's sick. It's a disease, I swear. Okay, table 5, host identification. This is the opposite part, and some of these IPs are the same. So for example, 177, again, the first thing that you have to do is identify that this is a Class B. And then from identifying that, the first 2 octets, unless subnetting is going on, which we're not going to do yet, but the first 2 octets are the network, the last 2 are the host. So I labeled it .18.4. 198 is a Class C, so that means the first 3 are, with a Class, I have this wrong here. With the Class C, the first 3 are the network portion, and then the last one is the host portion. I'm glad I'm going through this. 171. Now 171 is a class B. So again, this would be the host portion, but 1.199.31, I'm sorry, I said host. 171.2 would be the network, and then 199.31 would be the host. And what we mean by that, let me see if I can draw something. Okay, I'm going to try to draw something. Lord, help us now. At least I'm not going to try to sing something. But this will, I don't, oh wait, I do. I got a free, I got this free pen in the mail that's a pen and a stylus. So let's give it a shot. Okay, so what this means is here's your, oh, it does work. Sorta. Here's your router. It doesn't work. Stop inking because that's horrible. Let me start a new one. I had a stylus right in front of me that was supposed to make this all work. I'm so glad you're listening along with me and having fun. Or not. You don't really, well, you do have a choice. You don't have to listen. But sometimes I really miss not being in class with people. So, and I like subnetting. Okay, where did my inking go? View, review, start inking. Okay, what this means is we have, I'm still freehanding drawing with my mouse, but we have a router. Oh, this is painful. So that's a router, and it has a network address of 177. Oh, I cannot do that. Let's just try to insert text. It has a network address of 177.100.0.0. So if we're looking at question 1. And then you have all of these computers that are off of this router, you know, in this star type of topology. And all of these computers have an IP address. Those are supposed to be computers. All of these computers have an IP address, whoops, that's going to go from that basic router. So this would be the host part. Goodness, I know this isn't the best tool. I'm not going to spend too much time because I know what I know what I need to do. Let's insert a little text box here. So this, just draw me a text box, Word. So the IP address of this computer here would be 177.100.18.4. And then this one might be .5. And then this one might be .6. But when we have a class B, such as 177, the first two octets are going to be the same, unless you're doing subnetting. And then the last two, whoops, I'm missing one, .6. And then the last two are going to change, so it would be from 18.4, 18.5, 18.6, 18.7, all the way up to 255, and then you also have the second range. In the chapter, it talks about how many IPs are available for each class of IPs. Super, super important. So back to table 5, all you're going to do is identify what class it is. So 223 is a class C. So when you have a class C address, the network portion is the first 3 octets, and then the last portion is the host. So that one would be that. So in a class A, the first three would be the network. I'm sorry, the first one would be the network. The last three would be the host. And this also tells us how many IPs we can have on a class A. On one class A, you could have 2 to the power of 8 bits or 16 million IPs. On a class C, you could only have 254 IPs. On a class B, it's like 65,534 or something like that because you have 8 bits available. So that's table 5. And then the last table is the default subnet mask. Now this is important because we'll use default subnet masks until we get to subnetting. Now in some of your other courses you may have addressed subnetting, but you do need to understand it quite a bit for the CCENT and also for network engineering. But we'll just look at the 3 basics. A class B has a default subnet mask of 255.255.0.0. So anywhere that there's a class B, copy. 191 is a class B, right? Same IP. 223 is not a class B. 10 not. 126 not. 223 is a class C. 223 we just said was a class C. A class C has a default subnet mask of 255.255.255.0. And basically anywhere there's a zero, a series of ones, which is what 255 is, that means that that is the network portion. So that is my very quick short video that probably was a half hour long. I don't understand short, but that was my quick video on helping you with chapter 4. Read the chapter, understand IP, IP subnetting, IP router, save the workbook, submit this when it's all finished, and we'll spend more time on IP subnetting because you have to know it and it's super fun. And then also we'll get into packet tracer, which will be in our next learning module on actually doing some things with switches and routers. So thank you. I hope that you're enjoying the class so far. It's not just tedious bookwork, and although some of it is like definitions, but it doesn't hurt you. It won't hurt you. It'll make you stronger, I promise. So thanks again for listening, and I'll talk with you soon. 30 minutes.